Okay, today we're going to be looking at how to use a system of inequalities to represent a real-world or application, real-world application. How to solve a real-world problem using inequalities, a system of inequalities. So, what we're looking at here, and we are looking at this packet that is posted to Canvas. The first problem says the girls swim team is hosting a fundraiser. They would like to raise at least $500. They are selling candles for $5 and flower arrangement for $6. The girls estimate that at most they will sell 200 items. Write a system of inequalities, graph each inequality on the grid, and then we've got some little question we're going to answer having to do with the inequality. Okay, so first we know the girls swim team is hosting a fundraiser. We know that they want to raise at least $500. That's the first piece of information we're given. The next piece of information we're given is that they are selling candles for $5, flower arrangements for $6. So we're selling two different things, flower arrangements and candles. The girls estimate they will need at least, or that they at most will sell 200 items. At most, they will sell 200 items. Okay, so let's see what kind of inequality we can set up here. First of all, we know that they would like to raise at least $500. Now, there's two things that they're selling. The first variable we're going to let X, and this is going to be the number of candles because they're selling candles. The second variable Y is going to be the number of flower arrangements because they're also selling flower arrangements. Now we know that they are going to sell at most 200 items. So some combination of flowers and candles is going to equal 200, or going to be at least or at most 200. So the number of candles plus the number of flowers is going to be at most 200, okay? So 200 items. So that could be less than 200 or equal to 200. So our first equation, x plus y is less than or equal to 200. That's our first inequality. Our second inequality is going to be for how much money they're going to raise. So they want to raise at least $500. So they want to raise more than 500 or equal to 500. So it should be like this. Our equation is going to be more than 500 or equal to 500 because they want to raise at least 500. Now, for each candle, they're selling them for $5. So that would be 5 times the number of candles. And for each flower arrangement, they're selling for $6. So 6 times the number of flower arrangements. So the amount that they sell, $5 for candles plus $6 for flowers, should be more than 500 or equal to 500. So these are the two things we want to graph. Now, typically we would graph these in slope-intercept form. However, it's not, with these types of standard form equations that we set up, these are not in slope-intercept form. It's actually much easier to graph these using the x and y intercept. Okay, so if we want to graph the first equation using the x and y intercept, first we assume that x is 0 and find what y is. Then we assume that y is 0 and then find what x is. So when x is 0 for the first equation, then y would have to be 200. So 0 for x, 200 for y. That would be our y-intercept. Our x-intercept, we plug in 0 for y, 0 for y. And if it's 0 for y, then once again, 200. Okay, so this first piece means that if we don't sell any candles, we want to sell 200 flower arrangements, at most 200. And then if we don't sell any flower arrangements, we can sell at most 200 candles. Okay, so that's what I'm going to use I'm going to use those 2 points to graph the first line. Now, I want to know what 2 points I need to graph the second line. So 5x plus 6y greater than or equal to 500. So I want the x and y intercepts for these. So let's assume that I don't sell any candles. Then in order for these to be equal, so I would plug in 0. I would have to divide both sides by 6 because I have 6y. So I got 500 divided by 6, which is 83.33 or 83 1/3. Okay, so the way we come across that, we plug in 0 for x to find the y-intercept. So that gives me this because the x goes away, so I get 6y equals 500. Divide by 6, y is equal to 83.3. So 83.3 is going to be my x or y-intercept for this, and I also want the x-intercept, so I'm going to plug in 0 for y, and I'm going to do the same thing. Well, if you plug in 0 for y, then the x term is all that's left. So we're left with 5x equals 500, divide by 5, x equals 100. So if we don't sell any of the flower arrangements, then we would have to sell 100 of the candles to get $500. Okay, so I'm going to graph. So it looks like I should probably count by maybe 20s. So 20 or 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. Okay, so yeah, I'm going to count by 20s on the both axes. I'm going to count by 20s to get it. So 20, 40, 60, 80, and this is 0. 100, 120, 140, 160, 180, and 200. Okay, same thing on the other axis. 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. Kind of hard to see because I don't have a lot of room down here. Okay, so I'm going to graph the blue line. So 0, 200. So my first point for the blue line is right there, 200, 0. Second point for the blue line is right there. I'm going to connect these. Now I'm going to look at my inequality symbol to decide where the shading should be and how it should be shaded. So this is a less than or equal to sign. So it's going to be a solid line like I have it, and it's going to be shaded below because it's a less than. So all of this stuff satisfies that equation. Now I'm going to move to the second one. So the second one I have 0, 83.3. So I'm just going to put that at right here at 0, 80. All right. That's my first point. And then 100, 0. Let's see, 100, 0 is right here. I'm going to connect those. And I'm going to look at the inequality symbol, which is a greater than symbol. So it's going to be shaded above. Now, it's shaded above like this. However, what I'm looking for is where both of them are shaded. So both of them are shaded, which I'm going to do in green. That's the solution to the system of inequalities, which is in between these two lines. That's our solution. Okay, so I don't really need this. This is not the solution area. I'll just erase it. And I don't need this either. That's not the solution area. The solution area that satisfies both of these inequalities is in between these two lines. So I can use this information to now answer the third part. 120 candles have been sold. Use your graph to determine a reasonable number of flower arrangements that must be sold in order for the girls to reach their goal of at least $500. Justify your answer. So as long as I find an ordered pair inside the shaded region, the double shaded region, then it will satisfy both of these equations. So 120 candles have been sold, that's right here. So I can pick anywhere in this region So 120, I can pick anywhere in this region and have at least 500, okay? So I could sell 0, I could sell 20, I could sell 40, I could sell 60, okay? So I would say, let's just pick a random one. Let's just say right here. Okay, so if I sold 100 candles, okay, because X is candles, Y is flowers. So if I sold 100 candles, I could sell 40 flowers, and that would be fine. I would still reach $500. I would be more than $500. Okay, so anything in there would be fine. Reasonable number of flower arrangements that must be sold. Okay, really, it looks like I could sell anywhere between 0 flower arrangements up to maybe 80 flower arrangements, and I would be fine for my goal. Okay, now if I sell more than 80, then I end up selling more than 200 items. So anything, okay, 120 candles is already, because they're $6 a piece, or sorry, they're $5 a piece. So 120 candles is already more than $500. All right, and that is the first problem here. Let's look at another example here. The ninth graders are hosting the next school dance. They would like to make at least $500 profit from selling tickets. So at least $500 from profit from selling tickets. The ninth graders estimate at most 300 students will attend the dance. $3 for each ticket purchased in advance, $4 at the door. Write a system of inequalities. Okay, so the two pieces of things that we don't know, okay, we don't know X, which is the number of tickets advanced. We don't know Y, which we'll call the number of tickets at the door, okay? So X-axis will be the advanced tickets purchased in advance, so I'll put that on the X-axis. And Y-axis will be the number of tickets at the door. Okay, so what I want to find here is my well, first I need to set up my inequalities. So I know that there will be at most 300 students. So the number of tickets sold in advance plus the number of tickets sold at the door will be at most, so less than 300 or equal to 300. So that's my first equation, or inequality. My second inequality is going to be the cost. Okay, so there's $3 for the ones sold in advance, plus $4 for the ones sold at the door, and we need this to be at least $500. Okay, so it's going to be more than 500 or equal to 500. So now I have my two inequalities. I can graph them once again using the x and y intercepts just by assuming 0 for the x and finding y, and then assuming 0 for y and finding x, okay? So if I assume, for the first one, if I assume 0 for x, then y is going to have to be 300, okay, for them to both be the same. And that's the same thing if I assume 0 for y, that the x is going to be, or the y, if I assume 0 for x, then the y is going to be 300. So these are the two ordered pairs I will use to graph the blue line. Now, the ordered pairs I'm going to use for the red line, let's say that I assume x is 0. Okay, well, if I assume x is 0, then 3x becomes 0, and I'm left with 4y equals 500. Divide by 4. So y, 500 divided by 4, is 125. Okay, so if I don't sell any tickets in advance, then I could sell 125 tickets at the door to meet 500. Now, similarly, if I do the same thing and substitute 0 in for y, then the y term goes away, and I get 3x equals 500. Divide by 3, and 500 divided by 3 is 166.67. So 166.67. we put that on the graph, we will be able to round it. It's 166.67 if I don't sell any tickets at the door. Okay, so let me go ahead and label these. So I need to go to 125 and 166. So maybe I can go by 25s, I'm not sure. So 25, 50, 75, 100, 25, 50, 75, 200. Yeah, it looks like I can go by 25s, which would be fine. I guess I can go by 20s. 24, yeah, I'll just go by 20s. So 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. Same thing on the x-axis, 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. Yeah, I know it's hard to see because of my graph. It's kind of small. Okay, so my blue line is going to be at 0, 3, whoops, I guess I should not have gone by 20s because it's supposed to be at 300, so I need to go a little bit more actually. I guess I'm going to have to go by 50s to get to 300. So let me try this again. 50. And you know what? I'm going to skip 2 at a time so I don't have to write so much. So 100, 200, 300. I don't like that. Let's go by 75s. 25s? 100, 200. Nope, 25 is not going to work. I guess I have to go by 50s. So 50, 100, 150, 200, 250, 300, and 400. Okay. And then same thing, 50, 100, 150, 200, 250, 300, 350, 400. Okay. All right, so first I'm going to plot 0, 300, which is right here, and 300, 0, which is right here. Okay, so that's my first line, and I know it's hard to see. I'm sorry about that. Okay, and that one is shaded below. It's a solid line, shaded below. And then my other one, 0, 125. So 125 is like right here. Doesn't have to be perfect, between 1 and 150. And then 166.7 or 166.67. So that's like right here. Okay, it doesn't have to be perfect. And that's going to be a solid line. And that is going to be shaded above because it's a greater than symbol. So I'm looking for the overlap, and the overlap is going to be between these two lines. So let me see if I can, so graph each inequality. I've done that. Here's my overlap. I'll do my overlap in purple here. And it says, suppose only 30 people buy tickets in advance. How many people would need to buy tickets at the door? Identify one realistic solution. So let's say 30 people buy tickets in advance. So that's like right here. Okay, 30 people buy tickets in advance. Then it looks like anything in here would be okay. So let's say 30 is right here, then 200 people. Let's just go with this point right here. That would be a realistic solution. 200 people would have to buy tickets at the door. And you can see that 200 people plus 30, sorry, I messed that up. Because I'm looking for people that buy, so I have 30 people buy in advance. Oh, no, I didn't. So number of advance, that's the x-axis. So 30 people on the x-axis. Yeah, that's fine. So we would say 200 people. So if x is equal to 30, then y could be equal to 200. And the ordered pair 30, 200 is in it's right here. Okay, so it satisfies this because 200 plus 30 is less than 300, and it satisfies this because 200 times 3 is 600, so already we have more, sorry, 200 times 4, because it's the y-coordinate, is already more than 500. Okay, so that would be like a realistic solution.